Alright, in this video, this is post 6.2, so we've just learned that we can use the Laplace transform to solve a second order differential equation. And so what we'll do in this video is to solve 6.2, number 22, and that is to solve y double prime minus 2y prime plus 2y equals e to the minus t with y of 0 equals 0 and y prime of 0 equals 1. Good. So again, the idea is that if I were just to come across this differential equation, I would not solve it using Laplace transforms probably, because we already have a very nice suite of techniques for solving this. But we're doing this for practice, so let's go ahead and take the Laplace transform on both sides. And so therefore, the Laplace transform of y double prime is s squared y minus sy of 0 minus y prime of 0. And then we take minus 2. I like to use parentheses. Sy minus y of 0 plus 2 times y equals, these are y of s, right? 1 over s plus 1. Okay, and now because y of 0 equals 0, this term goes away. Y prime of 0, let's see, that term also goes away. And then y prime of 0 is equal to 1, so I'll replace that with a 1. And now I'm ready to simplify. S squared minus 2s plus 2 times y is equal to 1 over s plus 1 plus 1. Good. And so now when I do my inversion, my y of s is 1 over s plus 1 times s squared minus 2s plus 2 plus 1 over s squared minus 2s plus 2. Oops. Okay. Good. Now I need to perform some kind of partial fraction on this, and so I need to decide whether or not this guy is factorable. And so there's a couple different ways you could decide. B squared minus 4ac is one way. And if we do that, we get minus 2 squared minus 4ac. Is that positive or negative? I think that is a negative number. And so therefore, we're going to have complex roots. And so this does not, we would say that this is irreducible over the reals. Good. So therefore, I'm going to just focus on this piece for a minute and perform partial fractions on it. So let me erase the red here. White. Okay, so 1 over, do we remember how to do this? We have an irreducible quadratic. So that's going to be a over s plus 1 plus bs plus c, right, over s squared minus 2s plus 2. Good. And then following this along, I'm going to multiply both sides by the denominator. And so I will have 1 is equal to, let's see if I can get that. Let's see. It'll be a, can you read that? A times s squared minus 2s plus 2 plus bs plus c times s plus 1. Okay, now we could just choose values of s to plug in here. If I have irreducible quadratic, often I like to use when we equate coefficients. And so just quick as a bunny, if we go through here and figure things out, a squared minus 2a s plus 2a plus bs squared plus bs plus cs plus c. Good. And now let's look at our equations. For s squared, we have 0 is equal to a plus b. S terms, 0 is equal to minus 2a there, b plus c over there. Constant terms, 1 should be equal to 2a for that term plus c. Very good. All right, and so now we want to solve these. So from here we see that a is equal to minus b. That's nice. Right, so if I plug that in down here, then I'm going to have 0 equals minus 3a plus c, and 1 is equal to 2a plus c. And now, let's see, if I subtract both of these, or multiply both sides by -1, looks like I get, oops, 1 equals 5a. And so a is equal to 1/5. What was b? B is negative a, so b is minus 1/5. And then c is 1 minus 2a, and a is 1/5, so that gives me 3/5. Good, that wasn't too bad. So let's go back and rewrite everything. So I have that 1 over s plus 1. Oh, you know what? Let's go ahead and write down our y of s again. So our y of s is now equal to 1/5 times 1 over s plus 1. That's our a times a. This is this term. And then for this one, I'm going to rewrite it as 1 minus 1/5 times s minus 3 over s squared minus 2s plus 2. And then I still have my 1 over s squared minus 2s plus 2 that was left over. And so I'll deal with that in just a second. But it is possible to combine these two terms, right? But since it's already set up for us, we'll do it in just a bit. This term is ready to invert. This term is not. What do I need to do? I think I can rewrite that as s squared minus 2s plus 1 plus 1, right? And then this is a perfect square. So let me just rewrite everything. 1/5, I keep knocking my hand into something down there. 1 over s plus 1 minus 1/5 times s minus 3 divided by s minus 1 squared plus 1 plus 1 over s minus 1 squared plus 1. Very good. Okay. Now we can invert this guy. 1/5. Oh, you know what? Before we do that, let's go ahead and work with this. I need to rewrite this, right? Because I need an s minus 1 in the numerator, not s minus 3. And so I'm going to rewrite that as minus 1/5 times s minus 1 over s minus 1 squared plus 1. But then, let's see, I still need a minus 2 there. So I'll have a minus 2, and then it'll also, how am I going to write that? Let's not get too carried away first. Let's go ahead and just put a minus 2 there. And then we'll have our 1 over s minus 1 squared plus 1. Okay. So you can kind of see how this is going to work. 1/5, 1 over s plus 1 minus 1/5 times s minus 1 over s minus 1 squared plus 1. And then we'll have our minus 2 times 1 over s minus 1 squared plus 1 plus 1 over s minus 1 squared plus 1. Okay, now, well, we might as well just invert it. What the heck? So now we get our y of t. We're going to take the inverse Laplace, and we'll have 1/5 e to the minus t minus 1/5 times e to the t cosine of t minus 2 e to the t sine of t plus e to the t sine of t. So we at this point we really should simplify that. So it's going to be, oops, just go ahead and feed that through. I don't know why I'm waiting so long. Minus 1/5 e to the t cosine of t plus 2/5 plus 1 and 2/5 is 5 7/5. e to the t sine of t. Very good. Now, remember what the differential equation was. The ODE was y double prime minus 2y prime plus 2y equals e to the minus t. And do you see that what we have here is this piece is y sub h, and this piece is the y sub p, the particular part of the solution. Okay, so it's been a while since we've talked about that, but from our answer here, it does seem reasonable, because this piece will give us a homogeneous part. This piece will give us our particular part. Good. So there's our solution overall, and that only took us 11 minutes, even with all the algebra. Good job.